Yesterday in the video there was one mistake, and that was regarding the range for 32-bit. So it is from minus 2 power 31 up to plus 2 power 31. I think this I have explained in the WhatsApp. Now let's try and see what it actually means. That's, I think, more important. What is this overflow? So to start with, let's go to root. The command to start root, once you have set it up correctly, is just to type root from your command prompt. So now root has started, and I am going to start by defining a one-dimensional histogram. I call it H, and we'll give it a type which is short. I am choosing short. Yesterday we had chosen integer. Today I will choose short so that it will be possible for me to explain the maximum counts it can have in any particular channel. That limit will be 32767. It can't have at any channel counts more than 32767. So to demonstrate that, I am going to define a 1D histogram. I have explained that there are two ways you can do. One is with the pointer, and one is without the pointer. So let's do it with the direct method without the pointer. So the type will be th1s. So S stands for short integer, and short integer is 16-bit, and being 16-bit, the capacity on any channel will be maximum 32767. So let's again call it by some name. Let us say H, and in the arguments, the first argument is the name, in which case normally we just repeat the name is H and we just repeat it as H. After that we are supposed to give a title. You can give any title you want. For example, I can call it my histogram, and then comes the number of bins. So I had chosen yesterday, just for ease of demonstration, I stick with that 10 bins, and then comes the range. So 0. Now here the decimal should be put. You can get away without putting it also, but what you mean is that it's a floating point quantity. Whereas this 10, this is number of bins. This is an integer. This cannot be put with a decimal point. It would be wrong. So 10 is the number of bins. Then he is asking for the minimum value of x and the maximum value of x. So x is always floating point type in root. So the x-axis, any variable, is a floating point variable, and then we make a histogram out of it. So for the x-axis you must choose 0 with a decimal, and then put 100 as the, I am putting 100 as the maximum, so that should also be with a decimal point. So what I mean is actually 100.0. So that 0 can be dropped, but the decimal point should be put. If you don't put it by mistake, then still it will work, but let's get used to putting it correctly. So we should put 100 with a decimal place, and these are the arguments. As mentioned, there are 5 types of histograms. So this one is 5 types of one-dimensional histograms: th1s, th1c, th1i, th1f, and th1d. So we are using th1s, and in th1s the maximum count is going to be 32767. So this is my definition, and again, when you put a command, you have two options: either you end it with semicolon or you don't end it with semicolon. This is your decision. If you put it with semicolon, the command, if it is correct, it will be relatively silent and it will do the job. And if you put it without the semicolon, then if there is any output which he can write on the screen, he will write it. So let's try without the semicolon, and then we say that he reports something, some information. The information he reports is that the name is H and the title is my histogram, and the number of bins is 10, which is exactly what we wanted to have. So there are 10 bins. The bins are going to go from 0 to 100. So the first bin will be 0 to 10. The second bin will be from 10 to 20, and so on up to the 10th bin, which will be from 90 to 100. Then there is bin number 0, which is called the underflow bin, and this is going to have, if x values are negative, that means below 0, because our limit is 0, that will be called an underflow, and that will go, all values below x values below 0 will go into the underflow bin. And although we have set 10 bins, there is actually an 11th bin, and the 11th bin will be for all values of x above 100. Now this was underflow, overflow. It's not to be confused with what I am now demonstrating, and that is a vertical. This is horizontal. Horizontal means along x-axis. So this, whatever I said up to now, this refers to overflow and underflow bins. It is referring to the values of x, and this is not to be confused with the vertical axis. The vertical axis is actually the counts or frequency or the contents of the histogram, and this contents, when it overflows, that is on overflow in the vertical direction, it is different than your x overflow or underflow. So here I am going to demonstrate it, that what it is like. So let's remember the commands which we had learned yesterday. If I want to place a certain number in any bin, then that is called a set bin content. So if I take age and then I take set bin content, then I have to give the bin number. So let's say I am working with bin number 5, and I decide to put some counts in it, let's say 100. So this command means that 100 counts will appear in bin number 5 in the histogram age. And this was what it did quietly. Even though I didn't put semicolon, he had nothing to report. So there was nothing he reported, just the command came back. The prompt came back. Now I would like to display it, so I will put age dot draw. So the commands are case sensitive, so be careful while typing. So age dot draw is the command. Again, I can put it with or without semicolon. So it draws, and as mentioned yesterday, that or I will emphasize that it opens a canvas, and the name of the canvas is C1. It's because we never really created a canvas on our own. Actually, we should. Before you draw, you should create a canvas, and then only you should draw on it. But Root is intelligent, so he realizes that we never created a canvas. So he created one for you. On your behalf, he created a canvas. He called it C1. And he drew the histogram with 100 counts at bin number 5. Now I was trying to illustrate how many counts can this bin hold. So we saw 100 counts, there isn't any problem. If we were to put more, let's say we put 10,000. Okay. So this is 10,000 counts. Let's see whether it can do, and after it's over we need to update. The update can be done in 2 ways. I'll show you the first one like yesterday. So if I just put 10,000 counts, then it has put it, but the histogram, the picture is not updated. So I go inside the canvas and just click once inside anywhere, and it gets updated, and you will see that along the y-axis that we have reached 10,000 counts. The other way of updating, let's say I want 20,000, let me put some, say 20,300 counts. This is 10,000, this is 23,000 counts, 23,500 counts. The other way of updating it is that you can say h.draw again. So this also updates. Both the methods are possible. So if I do, then in one line it will set the contents also to 23,500, it will draw also. So again, you have to look at the canvas. You will see the change when I hit enter. I am going to hit enter now. You see that the y-axis has changed. He has put 23,500 counts, and the scale he has taken maximum as 24,000, which he wants a rounded number for the axis. So let's go up to the maximum possible value. 32767 is the maximum value, and let's see whether he is successful in plotting it. 32767. So I am going to put the maximum count possible, and you can see that he has successfully drawn it. There is no problem so far. So if you look at the y-axis, he has marked it, the scale, and in fact the count of this channel number 5 has gone to 32767. But as soon as I put 32768, then it will be an operation which will create a vertical overflow. So now something dramatic is going to happen when I put 32768, and this is what you will see. The picture will change entirely. So this is what I have got after I have so what has happened? So look at the y-axis carefully. You will find that the y-axis now, the maximum is 0 and the numbers are negative. So 0 is because all the other channels, they have remained with 0 content, so there is 0 sitting there. But at this channel, instead of plus 32768, he has gone to minus 32767. So because 32768 is not a legal 32-bit value, in short, it's not a short integer, 16-bit, not 32-bit. Since it is not a legal S value, TH1S, S means short, so short goes from minus 32768 to plus 32767, and after you cross plus 32767, then it will roll back and it will again come to minus 32767 and then go further from that point. So this was to illustrate what it means. So whenever you define a histogram, you have to realize that it is limited in terms of maximum counts it can hold, and according to your requirement, you should select whether it should be TH1S or TH1I. So some students then say that why do you want to bother with TH1S, because it has this problem. Let us anyway define everything as TH1I. It will never overflow because that requirement will be 2 raised to the power of 32. That's very large. And this one is going to overflow at 2 raised to 16. So why do you want to bother? Whether we need it or not, let's put it as TH1I. So that is to some extent correct. If you are not sure what to do, then you put it I, don't put S. But generally we put S for those cases where we are sure that is not going to overflow, and then we save memory. So any spectrum which you define, particularly when later on you will see 2D and 3D, they swallow up a lot of RAM on your computer. This is only one dimensional, and there are only 100 numbers. In this case, only 10 numbers. There are 10 bits. So this is not going to be big in term. But when you talk of real world examples, then it becomes important to make a decision, correct decision about the type of histogram, whether it should be integer, whether it should be short integer, or whether it should be floating point, or whether it should be double, because of the memory intensive nature of histograms. So histograms, they have occupied a certain amount of memory of your computer, and computer resources are always limited. So depending upon what you want to do, you must carefully define your histograms. Okay, at this point I am going to do what also I did yesterday. I'm going to fill this histogram with random data, Gauss random data. The idea is that we don't have at this moment any, from next time onwards, we'll get real data. But right now we don't have real data with us, so we are going to just fill it with some random Gaussian data so that we can illustrate various features. So this also explains to you how you can fill this with random data. So we will fill this with random data, and for that the way that we will do the random filling is, first of all, let's define it as a histogram which is of the type f, that is float, rather than integer, because we are now going to deal with floating point numbers. You could continue with the integer also, but for the purposes which I want to illustrate, I'm going to make a new one and I call it th1, but this time I use f. So f is of type float, and I call it h2. H we already have, so now I have h2, another histogram. So h2 will be the first thing, that is the name. Then comes something, so you can give any name you want to the title. So I call it as my random histogram. Give it a name, and then you need to tell again how many bins. So yesterday I had chosen 100 bins, I stay with that 100 bins. And then you have to give it a range, minimum x and maximum x. Again, they are floating point. This 100 is an integer, so no decimal point. But the minimum and maximum is along the x-axis, and this should be with decimal point. So I am going to choose -5. I put a decimal point also, and then I say +5, so 5 point. And this is my definition of my histogram h2. So I have retained in my memory h, so h is not gone, and a new one h2 has been added. So in a real life example, you will have many histograms. Right now we have so far one, and with this command a second histogram will be in memory at this point. So this is my second histogram with 100 bins. And in the next command I am going to fill it with random numbers. So I say h2, and then I ask it to fill with random. So fill random, and then the type of random number. So you know that there are many types of random numbers. We had illustrated it earlier when we did simulations. So the most common is of course uniform. Then there is Gaussian, so we are going to select Gaussian. So GAUS is the Gaussian generator in root. And let us choose some large number of events. I am going to choose 1 lakh. Let's say as an example. So this command will fill h2 with Gaussian random numbers. The range will be -5 to +5, because that's what we declared it while creating the histogram. So this refers to the vertical axis, and 1 lakh events will be random numbers will be generated, and it's going to fill up this histogram. So it's completed. The histogram 2 has been created. On my graphical screen I am still showing my first histogram. So let's now change it and try to show the second histogram. So h2 dot draw. So h2 will now be drawn, and this is your random histogram. Now the next command which I was trying to illustrate was how you can fit it again with the Gaussian function. Now this is already Gaussian, so naturally when you fit it with a Gaussian, the fit is going to be quite good. So let's do that. So you may remember from yesterday that the command is h2 fit, and fit, but you have to tell what function. So the fit is again the Gaussian function. So this command will try to make a fit through the data. You will see a curve, it will come in red, and it will appear on the graphical screen. So I'm about to hit enter. When I do that, you will see the fitted line in red has been drawn, and the values of the parameters of the Gaussian, namely the amplitude, its mean, and its standard deviation, are also displayed on the screen. Now, yes, so this I had done, but now some details were there which I hadn't told yesterday. So, one of the things which was only partly explained is that in this entire canvas there are now many elements. For example, this is a statistics element. This can itself be moved, and it can be also removed altogether, and its properties can be changed. So each thing is an element. Even this red line is an element. In order to access the elements from graphic screen, you should do view and ask to view the editor. Is the first option in view. So if I choose view and editor, then I get a left pane, and in the pane I have the possibility of accessing the different elements. At this moment it is showing C1 and it gives the type. So C1 is the name and the type is of the canvas type, that is T canvas. So all objects in root, they start with the letter capital T, and in this case the type of object is canvas. So this is because it has selected this. If I click anywhere here, then it is the canvas which is selected, but if I click inside, then you see now he has selected T frame. T frame actually refers to this boundary box, and if I click on the red line, then actually it didn't click correctly on the red line, it clicked on the blue histogram and H2. So and the type is given here, it is histogram of type F, floating point. So I have clicked the histogram. So the properties of these can be edited after you click correctly. Now this is the way that root runs. Sometimes it's very difficult to click because now the blue and the red line are very close. I want to click the red line and change, let's say, the properties of the fit. How can I do that? Because the red and the blue are almost very close, but still we can try. And here I clicked it unsuccessfully because it has gone to the frame. So some trial and error and you will be able to click it. If it doesn't work, then make the screen bigger so that you can now be a little bit more sure. So you see I was successful now after enlarging the screen. So this is one of the ways that root works, whether you like this feature or not. Anyhow, it is part of root, so this is the way that it works. So this line is in red color, and you can see the properties here. The line is in red color and the thickness of the line is 2. And if you want to change that, so instead of red, if you want to have some other color, let's say blue, let's say purple, I selected it, then you can see that the color has changed in my graph. If you want to line thickness to be more, I selected it and you can change it. So this is the way that you change things in root using the editor. Now the purpose of my the next thing which I want to explain is about the fitting. So you made the fit, but there is more to it than that. So now that we have selected the Gauss TF1 by clicking that line, you can see here he talks about the function and the name of the function is Gauss. So this is the function and its function is Gauss. And then the number of parameters which have been fitted, he shows it is 3, because the Gaussian has got 3 parameters, namely its amplitude, then its mean, that means position, and then its standard deviation, which means the width. And so this is what he is displaying, but you can also do more than that. So for right now, first what I'm going to do is I'm going to check mark this update. So there is a thing here saying update. So I click the tick mark on that, so that now updating will happen. And then I click set parameters. So this allows me to interact with the graphical system to change the values of parameters and then watch what happens to the Gaussian function. So I have clicked it. When I do that, another command window has opened which says set parameters of Gauss. So this allows me to change the parameters of the Gaussian and see what happens when I do that. So in order to make that work, first I am going to click immediate preview. So you see here immediate preview. I click the tick mark that, so that immediate preview will happen, means whatever changes I make will immediately show up in the graphical screen. So if I now were to, now there is a column here for fix, so I want to fix the, by constant it means the amplitudes. Its presently value is around 4000. I click fix and then I want to change it, right? So if I were to fix it, then of course it can't be changed. So first I'm going to change it, and let me put a smaller value, let's say 2000, and I want to see that if I make it 2000 instead of 4000, what happens. So then I click here fix, and you can see that this is what it has done. It has made the Gaussian amplitude to be half of what it is actually supposed to be. So in this way you can manually play with the parameter of the function and see how you can come close to the actual data. This is a process which I had demonstrated for you when we did fitting in lamps also, that sometimes you need to manipulate the fit manually and come close to your data, and then only allow the actual fit process to happen. So here this is what is possible in root. For example, the mean is supposed to be 0. If I make the mean say -3 and then fix it there, then the Gaussian is shifted so that it has gone to -3. If I were to make the sigma, that is the standard deviation, at present it is 1. If I make it 2, and if I were to fix it, then it becomes broad, as you can see. And if I reset it, then it comes back to where it was before I tried to make these manual changes. So this is one part of it which I had not been able to explain completely yesterday. I thought I would complete it before doing the next topic. The next topic is multipad canvas. So now multipad canvas is one in which I can display more than one histogram. Right now we are having two histograms with us. This you know. I will temporarily close the editor. I have the display. I am actually displaying here H2. We also have H, and both of them are available to be drawn. So if I could have done H.draw, and this is what I had. There was an overflow over there, so that's why it was looking like that. I will just remove that overflow so that it doesn't look so ugly. Let's put something more reasonable here. Okay, so this is my H, and H2, you know, we defined it just now with the Gaussians. So H2 draw looks like this. Now what if we want both? So now you know how to display one of them, one of the histograms at a time. But suppose you are interested to do both, then one of the options is to have two canvases. So this is canvas number 1, C1. You can make a second canvas and then you can operate with. So this is one way. The other way is that on one canvas itself you can divide the canvas, and that is what I am going to show you now. So what I am going to do is also show you how you can define a canvas to start with. So this canvas is called C1. I can work with this also, but let me close it. So C1 is now destroyed, and let me explicitly define a canvas. The canvas is of the type T canvas. So T canvas, you must always start with T, and by convention the next thing is also capital letter normally. So this is T canvas. If it changes color, then you know that you have typed it correctly. So if I was by mistake typing it as T canvas, then you can see it's wrong because the color didn't change. So I will get a hint that I'm doing it wrong. So I should type it correctly and proceed from there. So let me name the canvas myself. Instead of calling it C1, I call it something else. So I'm going to call it as my canvas, my C, let's say, for short. And this time I'm going to, it's similar, I'm going to define it in the pointer way. So then I will have to use the new keyword, the C++ new keyword, and then I will put the constructor for the canvas, which is T canvas, and then now I need a name, and the name is again, all these commands are similar, just as when you are doing it. The first thing is the name, and that will be the same as the name of the variable itself. And after that you can put a title, and this title can be anything. So this is your canvas title. So I put the canvas title, and that's it. So this should make you a canvas, and as you can see, the title of the canvas is showing up here. Whatever we put, the canvas got created. So this is manually creating the canvas. So now I can draw on this canvas. Now if I say H1 H draw or H2 draw, it will come on this canvas as usual, but I want to divide it. So I take my canvas, and then I ask for it to be divided. So for the sake of this illustration, let me divide it into 4 parts. Actually we need in this example only 2, but I'm just dividing it into 4 just to explain things. So this is a canvas divide command. Because my C is a pointer, so to access it we don't put a dot, we put the arrow. The arrow consists of a dash and then a greater than sign. So my C and then the arrow and then divide, and my divide will be 2 by 2. So that's because it will be a sort of there will be 4 divisions. So it will be divided into 4 parts, 2 along x direction and 2 along vertical direction. We'll get 4 pieces. So this is the way that I do the division. Now having divided it, there are now 4 parts to the canvas. So how do I access the first part? There are 4 of them. So they are called as pads. So I have divided it into 4 pads. My first pad, if I want to access, then I talk about my canvas, and then I refer to it. The pads are referred to by the cd command. So this is similar to change directory, but it's not a directory now, it's the change of the pad number. So if I say cd1, then the first pad will be made active. So by making the commands my c and then the pointer to cd1 makes the first pad active, and on this active pad I want to draw h1. So now the h. So if I draw h draw, it will come on this pad. So you can see now it's a small drawing. You can realize that it's a 2 by 2. It's a 4. There are 4 graphs possible. And my pad was 1 was active. Now let me make the second pad active. My C and then CD to the second pad. And on the second pad, let me draw H2. So here goes a drawing on H2. See? So I could make 2. You can make up to, in this case we have divided it into 4 parts. So 2 of the pads are not being used. So you can use it for 2 more drawings. So in this way, the pads can be defined, which divide the canvas, and then the histograms they appear on them. You can always enlarge the window when you are using. So this was about canvases, then dividing the canvas, and then changing the pad number, and then drawing on a particular pad. Now let's see whatever I have left out. I think most of the things are covered. One thing which is not covered is how do you make a logarithmic scale. I did explain the scaling, so if you were to zoom it like this, you can do it. Let me first get rid of the pad and have a single one. So let me make another canvas. Let me kill this canvas, and now let me draw only one graph. I think this will be okay. So now in this one, I'm just trying to unzoom it here. Yeah, so this is your back to having a canvas with only one drawing on it. I'm trying to drag this. Yeah, sometimes you can't grasp it properly, and thing which you don't want to drag gets dragged. Yeah, how do I make this y-axis logarithmic? This is what I want to explain now. So the way I am going to do it is so there is a command line way of doing it also. I will first demonstrate to you how to do it by using the graphical user interface. So it comes under the style of the canvas. So this is the canvas. This time the name of the canvas is C1_N3. See, we didn't make any canvas. We had destroyed C1, and we had destroyed our myC canvas also. So he created a new canvas. He calls it as C1_N3. Anyway, this is the canvas, and now the style of this canvas. So first thing is you click somewhere. You need to do the editor first. Edit and ask for the style. Not this one. I should say view editor. Yeah. So now we are in the canvas. Okay, we are not in the histogram, not in the frame, but click here the canvas, and here you find that you have an option log scale, X, Y, Z. We want the y-axis to be in log scale, so we click that, and this is what now you see here, 10, 10 to the 2 and 10 to the 3. So this is the way that you can set up the log scale. It's a property of the canvas. Right. So having explained this, we will now proceed to our next topic, and our next topic is going to be oh yes, first I should explain how you do this log scaling. So let me go back here to normal linear scale. Suppose I want to do this from the command line, then this also you should know. So the command line way is that it's a property of the canvas, actually of the pad inside the canvas. So that command is gpad, and then it points to set log y, set log y. So this is the command for making a logarithmic y-axis. You see, I entered it, and it made it logarithmic. If I want to make it again linear, then it is set log y, but with a 0 inside the bracket. So this command makes it linear again. So these are the commands I wanted to explain.